So what we are going to look at today is called Euler's method. I know it looks like Euler's, but it's pronounced Euler's. It's used when your differential equation is not separable. So you cannot separate the x from the y. If you want to do non-separable differential equations, there's a whole course called differential equations that you can take when you get to college if you want to, explore that. We are not going to do that in here, okay? But Euler's method is if you want to get an approximate value for a particular solution without actually finding the particular solution. So is it the exact answer? No, it's an approximation. We do a lot of approximating. Like a Riemann sum is an approximation for the area under a curve, and so on and so forth. So it's going to give you an approximation. This is technically what we're doing, and I realize this looks, a little bit intimidating. Here's what it means. To get your next x value, you take the one where you were and you add how much your step is. Typically, you're given that. They tell you what your step should be. Now it's real easy. To get your new y value, you take where you were. So to get y1, you take y0. You take where you were and you add that step value times the derivative at the previous point, because that is your rate of change. And you're saying, well, if I take that step amount times what my rate of change, it will get me close to what an approximation of the true y value would be. Okay, let's give it a shot. You're going to make a little table, x, y. And just as a heads up, this first one, we're going to have to fight through some fractions. Okay, after that, for the second one, I'll pull out the Desmos calculator. But for this one, sometimes they're non-calculator, and you got to be able to do it. All right. So what is our initial condition? Read through everything you were given here. What's the starting point? Yeah, 0, 3. Okay, so that's where we're going to start. And we want our step value to be 1/2. They just went and told us h is 1/2. Do you see it there? So for the x's, we're going to just count by 1/2. So it'll be 1/2, and then 1, and then 3/2, and then 2. How did I know to stop at 2? How did I know that that's how far I had to go? It says find f of 2. All right. If it had said find f of 1, I would have stopped here. If it said find f of 7, I would have had to keep going. Typically, they don't make you go very far because, just as a heads up, this is one of those things that's not difficult but pretty tedious. Okay. I do actually like it, though, because it's very formulaic. Like, do this, here's your answer. All right, buckle up. Here we go. This is y0, this 3, the y sub 0. We want to get y1. We're going to take where we just were, which is 3, and we're going to add on our step size, which is how much for this problem? Yeah, 1/2 times the derivative at the previous point. All right, so here's our dy dx. We're going to plug in 0 for x and 3 for y, and that's what's going to go here. Follow me? Okay. So if you plug in 0 for x and 3 for y, what do you get out of that? -6. Perfect. And here's my suggestion. Scribble that out. Not so much that you can't read it at all, but we're done with that. We don't need it anymore. And this is going to get a little overwhelming with numbers everywhere. So, X out the ones you don't need. Does that make sense? Okay, just to keep things as simple as possible. All right, so this is going to be 3. Half of -6 would be -3. And so we get 0. That's what goes right here. Do that 3 more times. Ready? Okay, so y2. You're going to take where you just were, which is 0 plus 1/2. Hey, Miss Cole, is it going to be 1/2 every single time? Well, for this problem, yeah. That's your step size, right? And then you want the derivative at the previous point. That's why I told you to scribble this one out so you pick the correct one. We're going to plug in 1/2 for x and 0 for y. What would you get out of there? I'm going to go fractions. 3/2. Okay, 1.5 is right, but just as a heads up, it's going to be easier if we do fractions for this. All right, so 0, that's nothing. When you multiply fractions, you're going to multiply the numerator, multiply the denominator. So 1 times 3 is 3, 2 times 2 is 4, 3/4 goes here. Scribble this out. Again, not so bad. Like, don't scribble it to the point where you can't read anything anymore, just in case you want to go back and read what you did, but we don't need that anymore, right? We're going to do that 2 more times. Ready? Is having fun yet? All right, 3/4 plus a half times the derivative at the previous point. So you're going to plug in 1 for x and 3/4 for y. That feels like a margin problem to me. Up to now, we were able to do it in our heads, and maybe you can do it in your head. Maybe you have a calculator in your brain. I'm going to do a margin problem off to the side. If I plug in 1 for x, that would just be 3 minus, now if I do 2 times 3/4, that would look like this. If you want to put the 2 over 1, if that helps you, sometimes for fractions that helps people, you're going to multiply the numerators and you're going to multiply the denominators. So that would be 6/4. You need a common denominator. So how many fourths is a whole 3? Wait, 12/4. Good. And if you subtract that, you get 6/4, which is 3/2. And I put that right there. Do a margin problem. And do not just rely on your calculator for this. They put these on the non-calculator part, and you have to struggle through it. All right? So let's see what we get here. This is going to be 3/4 plus 3/4. Cool, which would be 6/4, which is 3/2. So that goes right there. Good news. We only have to do it one more time. So last one. Whatever we get out of this, that's our answer. Oh, scribble this out. All right, how's it going to start? 3/2, that's where we just were, plus 1/2 times the derivative at the previous point. Okay, so we're going to plug in 3/2 for x and 3/2 for y. I have a feeling that's going to be a margin problem as well. If I plug in 3/2 for x, that's going to look like this. If you want to put the 3 over 1, if that helps you. If you're like, Miss Cole, that's too much work and I can do it in my head. Cool. It's just I'm doing the problem in front of a whole group of people that I'm trying to explain it to. So I'm trying to show every last little bit of it. Minus 2 times 3/2. Now the 2's are going to cancel there, so it'll just be minus 3. All right, this would be 9/2 minus, now how many halves? Is it 6/2, which would be 3/2. Cool. So that is going to give us 3/2 plus 3/4. I need a common denominator, which would be fourths. 3/2 would be 6/4 plus 3/4 is 9/4. Make sure you circle that or draw arrows or something. That's your answer to the whole question. So the answer to the whole thing is 9/4. Cool, you hung in there. That's probably the hardest one we're going to do. I shouldn't have probably done it first, but oh well. I'm going to use a calculator for the next one. Yes? Why couldn't we do it regularly for that one? What do you mean regularly? Oh, so this is not separable. You can't get the y's on one side and the x's on the other. It's not able to be separated. So you cannot actually solve it. No, typically multiple choice questions say use Euler's method. They don't beat around the bush. They're like, use Euler's method, step size of whatever. Like they're usually pretty straightforward about it.
Wait, so is there a way to get a non-approximate answer to that?
It's a whole course unto itself, and we're not diving into it. Okay? All right, let's try it again. Draw your little table. What's our initial condition? What's our starting point? 0, 1. Good job. What is our step size? What are we counting by? 0.1, 1/10. All right. 0.1. Where are we going to stop? 0.2. 0.3 is where we're going to stop. And the way we know is it literally says on the paper, find f of 0.3. As a heads up on your delta math, they don't give you this h value. They say do 2 steps and end up here. So you make 2 little boxes in your table. Like you want to do it twice and figure out where you end up, and then you can figure out what your step size is. Okay. This is not a Riemann sum. Well, yeah, like it'll be like on Bill, like dividing. Yes, you'll be able to figure it out, I promise. And if you can't, I'm here and I'll help you. All right, so where are we going to start? 1 plus 0.1 is our step size times the derivative at the previous point. So you're going to plug in 0 for x and 1 for y, which would give you -1. Actually, I hope we could do that without a calculator. It's going to be 1 minus 0.1, which would be 0.9. Okay, cool. We didn't even need the calculator yet. Now we're going to do it twice more. How will this one start? Yeah, 0.9 plus 0.1, and then I want the derivative at the previous point. So I want to plug in 0.1 for x and 0.9 for y. So 0.1 minus 0.9, -0.8. Getting my calculator ready here. All right, I'm going to type all of that in. Or is anyone trying to do it in their head? I'm going to try and type it in. Times, what is that? -0.8. All right, it comes out to 0.82. That's going to go right here. I'm not messing around with this one. I just typed it in. We did one where we fought through the fractions, non-calculator. This one we're going to type in. All right, one more time. We're going to scribble this one out. Y sub 3. How's it going to start? 0.82, that's where you just were, plus 0.1, your step size, and then you want the derivative at the previous point. So you would plug in 0.2 for x and 0.82 for y. So 0.2 minus 0.82, I'm getting -0.62. All right, now I'm going to put all of that in the calculator. -0.62. I got 0.758. And just remember, that is your answer. That's the answer to the whole thing. We're going to try one more. Sometimes they give you a table that you have to use and look up. And again, be aware, sometimes there's extra information in the table that you don't need. So we're going to draw our little XY chart. And what's our initial condition? Where are we going to start for this one? Yeah, that's g of x, which is something else. You have to juggle like x, y, g of x, sometimes an f of x. There's a dy dx, which is f prime. You know, yeah, it's a lot. What's the initial condition for this one? Where are we starting? Yeah, 0, -2. The only thing, I actually do really like Euler's method because it's very much just like do this and you get an answer. The only thing that's really a bummer, if you mess up the first step, every single other thing, domino effect, is wrong from there on out. Do you know what I'm saying? So you just got to be really, really careful. All right, what's our step size? 1/4. So 1/4, 1/2. Where am I stopping? 3/4, and then 1. All right, here we go. Y sub 1 equals, where do we start? Right, -2 plus 1/4 times the derivative at the previous point. So you're going to plug in 0 for x and -2 for y. So right here, if y is -2, this first part will be -4 plus, and then you want g of 0. Good. So it's -4 plus 8, which would just be 4. Actually, we might not need a calculator for this one because what's going to happen to that? It'll be, yeah, -2 plus 1, which is -1. Good job. -1. All right, 3 more times. Y sub 2, you're going to start with -1 plus 1/4 times the derivative at the previous point. So you're going to plug in 1/4 for x and -1 for y. So if y is -1, this will be -2 plus g of 1/4, which is 14. So -2 plus 14 is 12. 1/4 of 12 is 3 minus 1 is 2. Scribble out the previous one. All right, 2 more. You can do it. This one's going to be 2 plus a fourth times. All right, now you're going to plug in 1/2 for x and 2 for y. So if y is 2, 2 times 2, 4 plus 0, which will be 4. So what's that come out to? 3. Scribble out the previous one. Last one. Or you're done already? All right, hold on. This one's going to be 3 plus a fourth times. We're going to plug in 3/4 for x and 3 for y. So if y is 3, that would be 6 plus, what is it? 6 plus -4, which would be 2. So 2 times a fourth would be 1/2. So 3 1/2. If it wasn't written as a decimal, 3.5, you know what 3 1/2 is in fraction form? Because it's 7/2. I just don't want you to get all the way there and then not be able to pick your answer A, B, C, or D. Okay? Just real quick, here's how they often do it on delta math. They'll say, and you don't have to write this down, I just want to make sure you understand. They'll say start at 2. I don't know, give me a single digit number. Let's make something up. 5. Okay. They'll say start at 2, 5. They'll say do 2 steps. So you're going to put 2 other blanks, and they'll say end up at 8. So what would your step size be? Like, you'd have to count, right? So 2 plus 3 would give you 5, plus 3 would give you 8. So H is 3. Sometimes they don't come right out and tell you what H is. They'll say do 2 steps and end up at 8. Do you get what I'm saying? Like, and you'll have to just count on your fingers to figure it out. If you get stuck, just ask me and I'll talk you through it. But oftentimes they won't give you H. They'll say do 2 steps and end up here, and then you have to figure out what H is.